Okay, the next that we're going to do is we're going to use Solver, which is a tool that has for data analysis and optimization that Excel has. It's a lot easier and it's a lot quicker than what we've been doing right now. So it should be a lot more easy to understand and it's not going to be so much work. Okay, you'll ask why we did the other one. And I think it's important so that you would know the theory, that you can apply the theory, because then it'll be just a lot easier. The interesting part with Solver is you need to do all the steps. That is something you were going to have to do. So it wasn't a waste of time what we did in the first exercise because we need to do it again here. The first thing is to find the mean, which is the average. Okay, so we'll find the average of all of these. And we'll find the standard deviation. And this is the population because we have them all the observations. We didn't take a sample of them, okay? And this is our data, okay? So now that we have this, what we're going to do is, remember that we talked about putting everything in the same types of values when we normalize. That's something that's very important. We're going to normalize our data. And the way we normalize our data is with a function that's called standardized or normalizar. In Spanish, normalización, it's right here. And it basically asks three things. It asks for the number, which is going to be this. It's going to ask for the mean, which is this. And this one is, we're going to put that. And the standard deviation of the same. Make sure absolute values, okay? So we have it here, and you can tell, and we didn't pull it. So, I'm just going to pull it a lot easier. We need to make sure you can put both so that it doesn't move around. Because we really don't want this to move around. Okay, so here we have it. We pull it down. For everyone except for the A. Everyone check if you did it correctly. Okay. And this is basically what it says. This number right here is below the mean compared to the standard deviation, which means that this number is way below. We'll find another one. This one, for example. This one is above the mean because it's B, this one. It's above the mean, that's why it's a positive number. So we've standardized our data, and now we're going to randomly choose some of these numbers. Okay, this one literally is going to be random. We're going to have 5 clusters, 2, 3, 4, 5, and it's going to be these 5, okay? So what we do is we're going to go ahead, but we're going to take the z-scores. We're going to use VLOOKUP or buscar B. So we're looking for this number. in, oh, it's actually, it's all this. Okay, so we're looking for that one. I think it's going to be a lot easier, so we just pull the formula. We've already put that one. Then it's going to be the 2, 0. And if I write the formula correctly, it's going to be a lot of help. So this one is no longer looking for 2. It's going to be looking for 3, and it is this data, as well as this one. And this is looking for the 4th, which is this one. And this one is looking for the 5th, and we're going to move this data. Okay, so now we pull this, and you can tell 5. If I was to change this to 15, I could change it to 15 without a problem. Okay, the distance, if you remember, the distance is going to be our formula, which is called suma x menos y2. Our matrix X is, this is our matrix X, okay? And to our first cluster, okay? And this is going to be to our second cluster, and this is going to be to our third cluster. This is going to be to our fourth cluster, and this is going to be to our fifth cluster. And we also need to make sure that this is correct. Okay. Once you get the hang of it, it's fairly quickly and easy. Okay, you can tell. So it should be 0, 15 should be 0, 3 should be on the third one, the fourth one, and the fifth one. Now you take them in. Okay. There we go. That's our min value. And now we do same. This number is equal to this number, then it's a 1. Same is this number. This number, oh, it's right here, I wasn't seeing it, is equal to this one, then it's a 2. See if this, I'm sorry, this number is equal to this number, then it's a 3. If this number is equal to this number, and I need to put a C, this number is equal to that number, it's a 4. Same. If this number is equal to this number, it's a 5. If not, it's going to bring back an error. Big a lot of R's. And now we start closing. Okay. There it is. And our minimum value, we're going to sum it up of all of this. Oh, we have an error here, which we should look into. Okay. Correct. How about this? Sum. Oh. Need to be careful with that. That one is correct. That one is also correct. That one is also, I think I moved one. There it is. So basically, you need to be very, very careful when you do that. Okay, it changes a whole lot. The same one, and this is the fourth one. There it is. Okay. And the clusters right here. And I already have the formula, have all my clusters, and now I have my mean, which would be promedio. This is the same formula we did in the other exercise. And there it is. So we basically fill it up, and what Solver is going to do is it's going to avoid us, take away the hassle of us having to do 5, 6, 7 iterations. So what we're going to do is we go to data. Well, if you forgot, we were able to go here, options, where it says complements, down here, go, make sure you have solver. And in data, let me take my name down, it says solver. So you open it up, and since this is an optimization tool, what we're trying to do is minimize. And what are we trying to minimize? We are trying to minimize this number, okay? Because remember, that's the number we want to minimize, to make it less through all our iterations. So we say we want to minimize. What is it going to be changing? We want to change our anchor. We want to change our centroids. So we put that, and now we add the conditions. What are the conditions? And one is that these numbers have to be, and this is those numbers are less than 150. Okay? The next one is that these numbers are greater than 1 because we have one number and then we had 150. Okay? And the next one, which is really important, is that they're whole numbers. So here, and it's an int, which means whole. And we have our 3. And it's very important here, this is not linear. We don't want something linear. Remember, it's predictive, so we want to keep evolutionizing, and that's what's called evolutionary. And you put resolve, and it's going to take a while. And if you can tell right here, basically what Excel is doing, it's changing up these numbers. Using all these formulas, changing up these numbers until this is the lowest it can be. And it's going to give us a solution. And depending on your computer, it might take a few minutes, or it might take 2 or 3 minutes, 5 minutes. It's really going to depend on your computer. So let's give it a little bit of time right now. With these random numbers, we had 131 for our the sum of our squared errors. Okay, so it's working. Let's give it time to work. I see that it's taking a little bit too long. Then I'll pause it so that you are, there it is. And so it says that Excel, this is the best solution that it found containing these particular restrictions. So we say, okay, we go and opened another file, but it says that this is the best combination. 55, 46, 52, 150, and 140. It's the best centroids that it was able to find. Okay,